Now let's talk about multiplying and dividing numbers and considering our precision with that, our significant figures with those numbers. Let's say, for instance, I wanted to figure out the area of a circle with such a diameter, with this 19.5 millimeter diameter. Well, area of a circle is radius squared times pi. So I'm going to need to take half of this square and multiply by pi. Cool. Brings up an interesting point with regard to significant figures. I'm about to divide this by the number 2 with no zeros after, ostensibly. But this is an exact 2. All right, this is not a 2 that I measured on some instrument that I need to be honest about reporting just how precise it is. No, this is an exact 2. And so it'll have no effect on the precision of our outcome. So 9.75 millimeters. To find the area of the circle, I'm going to have to square that number and then multiply by pi. So we're looking at 9.75 times 9.75. Now, put this in our calculator, we get 95.0625. Now this brings up the question, do I know this value out to the 10,000th of a square millimeter? No. But I can't do what I did with addition and just consider the number of decimal places, because that's not really accurate either. For instance, say I wanted to multiply that radius by some small increment that only had one just decimal place. I could be pretty confident about the number of decimal places here. Recall, this was an exact number, so I'd be losing a lot of information. No, when we multiply and divide numbers, we keep the smallest number of significant figures. Contrast that with the smallest number of decimal places with the addition and subtraction. Multiplication and division, keep the smallest number of significant figures. Well, recall from what we said before, 9.75 would have 3 significant figures, and of course so does the other. So that means that our answer can only be reported with 3 significant figures. So that means we have to round to this place here, the 10th place. So we look at the one after, it's a 6, so we're going to round up. And there's our radius squared, which of course is actually a quarter of the square that would bracket this circle. So we still have some work to do, but that's all right. All right, so next we need to use our value for the radius squared, multiply by pi. Now remember what I said about further calculations. We should do our calculations with this number here, which is why we left it and just crossed it out. All right, and then we'll do our rounding at the end, remembering that we only have 3 significant figures to work with in our final answer. Memorizing a whole bunch of digits of pi is a poor use of our time here, but the important thing to note is you should use a value for pi that's at least as precise as the answer you want to get. You would hate to use, say, for instance, 3.1, because then you're actually giving up significant figures and you can only report your answer down to 2, which is a waste, okay? Especially when most calculators will have pi programmed into at least 10 decimal places. So let's do that. I get 298.647 and change. All right. And now we can go back to our 3 significant figures that we determined would be our best precision, the most we can give. In this case, that would mean rounding to the ones place. So 299 millimeters squared is the area of the back of this pen. At least if we're going to limit ourselves to the use of my simple ruler as our measuring instrument.